Today we are going to be talking about the converse of the Pythagorean theorem. So we've been talking about converses quite a bit this year, a few times. Somebody remind me what a converse is.
It's when you flip-flop.
It's when you flip-flop the statement. So the if becomes the then becomes the if. So yesterday we said the Pythagorean theorem is if it's a right triangle, then a squared plus b squared equals c squared. So the converse to that would be if a squared plus b squared equals c squared, then it's a right triangle. So that's what this first theorem says. If the square on one side of a triangle is equal to the sum of the squares of the other two, if c squared equals a squared plus b squared, then it's a right triangle. So what we're going to have today is three numbers that we can test according to the Pythagorean theorem. And if it creates a true statement, that means those three numbers must have been numbers that made a right triangle. Some common right triangle sides are 3, 4, 5. Or we can multiply that. If I multiply it all through by 2, it gives me 6, 8, 10. Or by 3, it gives me 9, 12, 15. Another common group of right triangle numbers is 5, 12, 13. The last two aren't quite as common. You don't really need to memorize these. They're just time savers. So if you had a problem that gave you a right triangle and it said this side is 3, this side is 4, find the other side. If you recognize these, you can just say, oh, the other side's 5. And you don't have to go through the process of the Pythagorean theorem. You don't have to memorize them, though, because you could just apply the Pythagorean theorem and figure it out. So it's just a time saver. So if you're like, I don't really feel like adding that to my list of things to memorize, that's fine. Then you'll just do the Pythagorean theorem for every problem. Otherwise, sometimes you might recognize these and they'll save you time. When we say these are common, we don't necessarily mean that they're like around anytime you see a triangle on something that is going to fit one of these, but they're common to math classes and math tests and like ACT tests. We like to put these on there because the numbers are nice and clean, so it just makes them easier to work with. So they're common to kind of the math world, but they're not necessarily common in the real world. Theorem 8.4 and 8.5 say, well, what if c squared doesn't equal a squared plus b squared? We can actually still figure out what kind of a triangle it is. If c squared equals a squared plus b squared, it's a right triangle. If c squared, whatever the biggest side is smaller than the sum of the other two, that means that side was too small to really be a hypotenuse, which means the angle across from it must have been too small, so we get an acute triangle. If c squared is bigger than the sum of the other two, that means that side turned out too big, means the angle across from it must have been too big. So it's not a right angle, it's an obtuse angle. So given three numbers, we can tell what kind of a triangle they would make, an acute, right, or obtuse. And that's what our problems for today are going to look like. So let's look at some example questions. So for example, if you had the numbers 6, 8, and 10, we want to test them and see what kind of a triangle they're going to make. Always put the biggest one alone. The biggest one must be alone no matter what order the numbers are given to you. The biggest one has to be on the side by itself. So what we're going to test is, does 10 squared equal 6 squared plus 8 squared? So what is 10 squared? 100. What is 6 squared? 36. What is 8 squared? 64. Does 36 plus 64 equal 100? Yes, it does. That's a true statement, which means these three numbers would create a right triangle. Since c squared equals a squared plus b squared works, it must be a right triangle. Let's try 4, 8, and 6. The biggest one must be by itself. So that 8 is the biggest, even though it wasn't the last or the first, it's the biggest, it has to be by itself. So we're testing, does 8 squared equal 4 squared plus 6 squared? What is 8 squared? 64. What is 4 squared? And 6 squared? What is 16 plus 36? 52. So that side was too big. The one that we were thinking might be a hypotenuse was actually too big to be a hypotenuse, which means that this triangle must actually be an obtuse triangle. Always think about what that single side is doing. The single side was too big, so the angle's too big, it's obtuse. Okay? Let's try 12, 10, 8. Which one am I going to put by itself? The 12. The biggest always has to go alone. And we're going to test, is that the same as 10 squared plus 8 squared? What's 12 squared? 144. 10 squared? 100. 8 squared? 64. So I get 144 is smaller than 164. So the side that we're thinking was maybe a hypotenuse was actually too small to be a hypotenuse, means the angle was too small to be a right angle. So this triangle is acute. Okay? Questions so far? Sometimes the numbers they give us aren't quite as pretty. So let's try a couple without real pretty numbers. If you cannot tell which number is the biggest, just plug it in a calculator and get a decimal approximation for it so you can tell which one is the biggest. So square root of 14 is bigger than the square root of 7, so the square root of 14 is the one that has to go by itself. Okay, if you can't tell what one's the biggest, it's fine to just plug it in the calculator, turn it into a decimal, and see what's the biggest. Still work with the square roots when you do the problem. Don't work with the decimals, but just to test what's the biggest, you can check out the decimals. What is the square root of 14 squared? 14. We talked about yesterday how those cancel each other and leave us just what's inside. Same thing on the other ones. And this is a true statement. So what kind of a triangle is it? A right triangle. One last one. Let's try 4. 4 square root 3, 8. I can tell 4 times the square root of 3 is going to be bigger than 4. I may or may not know whether it's going to be bigger than 8. So that's where you can just type it in your calculator and see. 8 is the biggest, so 8 will go by itself. What's 8 squared? What's 4 squared?
16.
We talked about this yesterday. How do I square something that has the two parts like that? Square it all. So if I square the 4, I get 16. And if I square the square root of 3, I get 3. And I multiply those together, it gives me 48. What is 16 plus 48? 64. So this works. It's a true statement. So what kind of a triangle is it? A right triangle. Okay? All right. Your homework tonight is from lesson 8.3.